Hi, welcome to Moscan. So in today's video, we are going to take one question which is very interesting question. The circuit is drawn here. You can see one pass transistor is given here whose supply is given as 8 volt. Gate input A is given in the form of a periodic signal whose magnitude is going maximum till 6 volt and output of this pass transistor is being fed to a CMOS inverter whose this is an different kind of CMOS inverter. If you see, PMOS source is connected to ground and NMOS source is driven by output of this pass transistor. The CMOS inverter input is denoted as Vin, whose graph is also given here in this question, which is ranging from -5 to 7 volt. Now the output of the CMOS inverter is again going to a switch, and now the output of this switch is being fed as an input to a latch whose supply is 5 volt, and initial condition for this particular net is given as 0.5 volt, and we have to draw the output V out for this question. And one more information which is given here is for all the transistors threshold voltage can be considered as 1 volt. So this is an interesting question because it is a combination of pass transistor, a different kind of CMOS inverter, and a latch circuit. So let's start solving this question. So we'll start step by step. So let's start solving from here onwards. You can see supply is given as 8 volt and A input is drawn here in this question. You can see the input is starting from 0 volt, then it is going till 6 volt. So threshold voltage is also given as 1 volt. Once we will start applying input A at this gate, initially it is sitting at 0 volt, so this NMOS will be turned off. Unless VA voltage will not reach more than 1 volt, this NMOS will not get turned on, because in order to get this NMOS turned on, VGS should be greater than VT. VT is 1 volt, so VGS should be greater than 1 volt or equal to 1 volt, so that this MOSFET can get turned on. So if I have to draw this particular net, let's call this net as VB net. So if I have to draw VB waveform corresponding to VA, so how it will come? Let's try to draw this. With respect to time, I am trying to draw VB. When VA is 0, VB will also be sitting at 0. Once VA will reach at 1 volt, it will start getting turned on, and once VA would be sitting at 6 volt, the output will come 1 volt less. So that means VB maximum will come 5 volt, right? Because this MOS has to be turned on, so till 5 volt it can pull down this node. Because till that point, if you calculate VG minus VS, VA would be sitting at 6 volt, VB maximum will come 5 volt. So till that point, this MOS will be turned on. As soon as if we try to charge this node beyond 5 volt, this MOS M1 will get turned off. So maximum this node can reach till 5 volt. VB will follow exactly like VA. The only change here would be maximum voltage of VB would be equal to 5 volt only instead of 6 volt of VA. So this is how VB will come, and the maximum magnitude would be of 5 volt. So this is the first part which we have gotten. Now we need to use this VB as a voltage for this M3 source, and we have to calculate this node. Let's call this as VC net. So we need to find out how VC will come. Once VC will be known to us, then only we can draw V out. So you can see for the CMOS inverter, input waveform is drawn here. So it is ranging from -5 volt to 7 volt. And now we know the VV net also. So let's try to draw the VC waveform. VC again we can draw like this. Let's call this as time axis, and let's call this as voltage at C node. So if you look at Vin waveform, Vin is starting from -5 volt. One more thing which we need to know here is that Vin is -5 volt till the half time period of VA. I mean, there is a delay between VA and Vin waveform. Vin is half cycle delay than VA. So this point also we need to consider while drawing the VC output. So Vin is starting from minus 5 volt, and once it will be sitting at minus 5 volt, M3 source would be sitting for 0 volt for some time and then for 5 volt for some time, right? Because Vin is changing its state from minus 5 to 7 at the after half time period of VA, and VA and VB are in same phase. So till here we will consider Vin as minus 5 volt. So when Vin is minus 5 volt, let's start to solve for this particular part. When VB is 0, so Vin is minus 5, VB is 0. Anyways, this NMOS will be turned off because VGS will be negative here. And if we talk about this PMOS, its source is sitting at ground, Vin as minus 5 volt. So it will be turned on because VSG, if we calculate for this PMOS, V source is 0 and VZ is minus 5. So ultimately you will get 5 volt as VSG, which is greater than VT, which is 1 volt. So this PMOS, M2 MOS will be turned on. And what will happen then? VC will be pulled to 0 voltage, right? So till the point input is minus 5 volt, our output VC will be sitting at 0 volt. Even when your source node of M3 will change its state from 0 to 5 volt, even in that condition also this M3 will be turned off because VG is still minus 5 volt and VS is 5 volt, still your VGS is negative, so this M3 will be turned off. Now what will happen when Vin will change its state from minus 5 to 7 volt? Let's try to draw that. So when Vin will be coming at 7 volt, at that time for half cycle, this VB node is sitting at 5 volt. So if we calculate the VGS for MOS M3, Vin is 7 volt and VB is 5 volt. So VGS is 2 volt, which is greater than threshold voltage. So what will happen for this half cycle, VC will come 5 volt. Because our VB is sitting at 5 volt, VGS is positive, so VC net will pull at 5 volt value. So till half cycle, it will be sitting at 5 volt. Now as soon as this node, VB will change its state from 5 volt to 0 volt, so still your M3 will be turned on, VGS will become more here because Vin is still sitting at 7 volt and VB net is going to 0 volt. VGS is 7 volt, but now VC value will be pulled to 0 volt instead of 5 volt. So this is how the waveform will come till this point. Now, if you see, at this point, your V in is changing its state from 7 volt to minus 5 volt. And till this point, it will be sitting at minus 5 volt. So again, like the previous case, when Vin is minus 5 volt and your VB is 0 volt, irrespective of whether your VB goes to 0 or 5 volt, when Vin is minus 5 volt, your M3 will always be turned off and your M2 source is already fixed as ground. So till the point Vin is minus 5 volt, VC will always sit at 0 volt. And then for half cycle, it will be turned on and then it will again go to 0. So this is how your VC will look like. It will have maximum magnitude of 5 volt, but its on time will be half of what VB was having. If VB is having on time of T, so VC will have half on time of T by 2. So this is an important concept in this question. That's why it was important, because here you can see through blue mark it is shown this Vin is half cycle delayed to VA, and this we need to consider while drawing this VC. Now we know the VC, then it's become easier for us to draw V out. One more important aspect of this question is that it is given to us that initial condition of this net is 0.5 volt. How it will be used, let's try to understand this part. So now we only need to solve this portion. Till here we have solved. M4 gate, we know this VC is M4 gate and we need to draw V out. This is an NMOS, M4 is an NMOS. So till let's try to draw V out. With respect to time, we are trying to draw V out. Till the time VC is 0, this NMOS will be turned off, right? Because VGS will be 0 here. So this node is floating kind of, but initial value for this node is given as 0.5 volt. So let's assume this is sitting at 0.5 volt till this point where your NMOS is turned off. When this node is sitting at 0.5 volt, this is basically a CMOS inverter connected back to back. So if I try to draw it in form of circuit, so something like this, it will be implemented at transistor level. This is V out, this is V in, and this is 5 volt. Supply is given as 5 volt. Now input is 0.5 volt and threshold we have to calculate 1 volt for each MOS. That means this NMOS will be turned off because VGS is less than VT. So this NMOS is turned off. Whereas if we talk about this PMOS, its VSG 5 volt minus 0.5 volt is equal to 4.5 volt is greater than VT. So that means this PMOS is on and V out will be then equal to 5 volt because this PMOS will pull up this voltage to 5 volt. So till the point our M4 is off, our V out will come 5 volt because of this initial condition. So we can draw like this, V out is sitting at 5 volt till this point when input is 0. Now what will happen, once input will go high, that means 5 volt, this NMOS will become on because 5 minus 0, that means VGS is 5 volt which is greater than VT of 1 volt. So this node whose initial condition value was 0.5 will now sit at 0 volt. This will be pulled down to 0 volt. But again, if this goes to 0 volt, if you see from the circuit point of view, this input is 0 volt. So again your NMOS would be turned off, and this PMOS will be having a full VGS of 5 volt. So this output will be pulled up to 5 volt. So even though your VC value will change its state from 0 to 5 volt, but your output will remain at 5 volt even in this condition also. So till the time your VC is sitting at 5 volt, your output will still sit at 5 volt. As soon as your input will go to 0 for the second part, since this is a latch, so now this value will be sitting at 0 volt because it will hold the previous state, right? Now 0.5 volt will not come in picture, it was only for initial condition. Since this M4 has already turned off in one cycle, so once in second cycle it will turned off, this net will hold its previous state, so it will be sitting at 0 volt. That means output will again come as 5 volt. So throughout the time range, your V out will always sit at 5 volt. So this is the answer of this question. It was very interesting question because if you see from diagram point of view, we had a lot of things to consider like delay part, and then we had to consider the initial condition, then we had to consider the second part where initial condition will not come into picture because latch will hold the previous state. Although the output is not changing state, output is same 5 volt, but this was an important point. So this kind of questions are very useful question because multiple concepts get involved in this kind of questions, and once you have the clarity about each and every concept, you can only solve these questions. Thank you so much for watching this video. If you found this video useful, please share with your friends, and if you haven't subscribed our channel, please do subscribe.